Publishing a custom vision model involves making a trained image classification or object detection model accessible for integration into applications or services. It allows external applications to leverage the model's capabilities, facilitating automated and scalable use cases. A model must first be trained and adequately evaluated to ensure accuracy and reliability before publishing becomes appropriate. Published models advance the process from experimentation to real-world integration, essential for practical deployment and operational usage. Before publishing a custom vision model, specific prerequisites must be fulfilled: complete training with representative image data, comprehensive evaluation with performance metrics, accuracy, precision. Ensure model performance meets predefined acceptance criteria. Azure subscription with appropriate resource creation privileges. Sufficient quota and resources in Azure Custom Vision Service to host published models effectively. Attention to these prerequisites ensures smooth publication and optimal integration within user applications and services. Publishing a trained model in Azure follows these straightforward steps. Navigate to Custom Vision Portal. Select the project and iteration to be published. Click on Publish to initiate. Specify a unique published model name. Choose a prediction resource already associated with Custom Vision. Confirm publication to finalize. These steps leverage Azure's intuitive Custom Vision interface, simplifying the publication process and preparing the model for external use. Prediction resources in Azure Custom Vision serve as hosts for published models. Critical points include: resources can be Azure Compute instances supporting REST APIs. Ensure selected resources have adequate performance and scale characteristics for intended usage. Configuring resources properly impacts latency and throughput significantly. Proper understanding and management of prediction resources affirm effective scalability and reliability when deploying custom vision models to production environments. Published custom vision models can be consumed using a REST API. A typical interaction includes endpoint identification, retrievable post-publication, authentication via prediction keys provided by Azure, HTTP post request submissions containing image data to endpoint, HTTP post/custom vision/v3.0/prediction/project ID/classify/iterations/iteration name/image host. Prediction key. Content type. Application/octet stream. Responses include predictions with labels and confidence scores confirming model functionality. Effective management of published model iterations entails operations such as reviewing published model performance regularly, replicating high-performance iterations across multiple instances, converting iterations to default models for simplified API endpoint connectivity. Unpublishing models no longer needed to manage resources and reduce costs. Efficient iteration management contributes directly to maintaining optimal performance and resource utilization. Scaling published custom vision models includes considerations such as selecting adequate Azure resource tiers based on traffic, establishing auto-scaling rules for robust performance, expanding available compute and networking capacities to handle increased prediction load. Proactive and careful scaling strategies provide improved response times, increased model availability, and robust operational stability under varying workloads. Maintaining security for custom vision models published in Azure requires secure management of prediction keys and credentials, regularly auditing API access logs for unusual activity, employing network security practices, including Azure Virtual Network Integration, considering encryption both at rest and in transit. Applying stringent security practices helps prevent unauthorized model exploitation and promotes secure usage of AI services. Effective lifecycle management and model versioning practices involve clear naming conventions to identify iterations easily, transitioning smoothly between model version rollout and retirement, using rollback strategies to restore previous iterations quickly, continuous evaluation frameworks to facilitate updates and improvements routinely. Lifecycle management optimizes model productivity, adoption ease, and customer satisfaction. Adhering to best publishing practices ensures the effectiveness of custom vision models. Rigorous performance validation prior to publishing. Clear, consistent version labeling for ease of use. Selecting resource tiers optimally addressing intended usage scenarios. Documenting models extensively and clearly defining API usage for developers. These considerations minimize implementation difficulties, reducing operational risks, and supporting sustained model performance. Published custom vision models commonly benefit applications like automated quality control inspection in manufacturing, retail inventory management through automated shelving analytics, medical diagnostics support through image classification of conditions, autonomous vehicle navigation, improving safety and reliability. Reviewing diverse use case examples highlights the broad applicability, flexibility, and utility of publishing models effectively. Post-publication maintenance and monitoring routines involve continuous tracking of usage metrics and performance, detecting model drift with regular accuracy checks, timely retraining of the model with updated image datasets to maintain efficiency and accuracy, implementing alerts and thresholds for maintaining service levels actively. Routine monitoring preserves model health, extending useful life and ensuring continued alignment with operational requirements.